I'll make a start. So hello everyone, you're very welcome to today's webinar, Small Cell Deployments, the critical factors involved in achieving swift approval. My name is Anne-Marie and I'll be your moderator today. I'm very pleased to introduce you to today's speaker. First up, we have Dr. Jonathan L. Kramer, is the founding partner of Telecom Law Firm, a California-based law firm and consultancy on wireless and broadband matters, serving governments and landlords throughout the US. As a government side expert, Jonathan is joining today's webinar as an independent contributor, not endorsing any product or vendor. Next up, we have Laurie Kendricken, a senior paralegal and senior project manager who heads up Telecom Law Firm's wireless application processing staff. She has processed nearly 3,000 wireless projects, including small cells, macros, DAS, and generators, ranging from new sites, modifications, and renewals. She is also a lecturer on wireless application processing for the firm's government clients. Next up, we have Tim Sill, the VP of Technology and Business Development for Alpha Wireless. He is a veteran wireless executive with over 25 years experience, and throughout Tim's career, he has professionally consulted, developed, and innovated telecommunication solutions, such as the first femtocell product and the concealed antenna node, which he'll be sharing some information on today, and OTT applications. Also joining us is Dee Keane, Marketing Coordinator for Alpha Wireless, who's supporting for marketing today. So we will be recording this webinar and it'll be available on demand. Following this webinar, it'll be available tomorrow. We would love to hear from you, so if you have a question, please feel free to place it into the Q&A tab at the bottom of your screen, and we'll be holding an open Q&A at the end of this session. We'll also be launching a poll, so please feel free to vote on that poll. I'll be launching that very, very shortly. And then essentially we're ready to go, so I'm going to be handing it over to Tim Sill, who will be taking it from here. Thank you very much, everyone.
Okay. Thanks for that kind introduction there, Anne-Marie. Welcome, Jonathan and Laurie, for joining us today to discuss this very interesting topic, given the amount of interest in small cell deployments. Most everyone in the wireless industry really knows about the challenges faced with gaining approvals for deployment. During this session today, we will be discussing some of the key topics that we hopefully will educate others on the ways to minimize delays for the approvals, as well as touch on the approaches that that can help reduce deployment times as well as costs. Jumping right in, Jonathan and Laurie, starting off, why do local governments even care about camouflaging wireless sites?
Let me start by welcoming everyone who's participating today and listening after the fact. This is an issue that is really on the upswing now, so this is particularly timely to talk about it. And Laurie and I are going to talk about it from the perspective of the other side of the planning counter, the other side of the public works counter, because that's where we work. We work for local jurisdictions and advise jurisdictions all over the country about small cell deployment, macro cells, all of that. So as we go through, I've got to give you a comment. That wasn't the trigger word. You'll figure out what that means in a minute. I have to give you an admonition, which is when we say things, we're saying things that we believe in from general practice, but they're not they're not to be taken as saying that every jurisdiction should follow this, or, well, Kramer said it, so you got to do it. That's not how it works. But on the other hand, what we're going to tell you are general consensus items, since we talk to planners all over the country and city attorneys, county councils, and hopefully you'll glean some things from that. All right, so why is this important? Smaggle-bloggle. See, that's the trigger. That's the current trigger word to change the slides, since Tim's in control of the slides. When we start out you have to understand that your viewpoint of a wireless project, a small wireless project, is very different from the community's viewpoint. And by talking about this now, we're really going to kind of highlight some of those differences, which will help you understand where the government side comes from on this. And for most of you who are building wireless facilities, your position is this is a short project. We're in, we're out, got it optimized, got it configured into the net, and we're moving on to the next 47 that are already in queue. But from the government perspective and the constituents that we represent, we look at this as a 50-year incursion into the public right-of-way. And it's not just that there's going to be a few. I think each of you who represent the constituents, the carriers, the builders that you're representing know that we're talking about many per square mile per company. And we know that too. So when you come to the planning counter and say, well, we're only building 2. Yeah, you're building 2 right now, but in the next 2 or 3 years, you're going to be up to 15 or 20 per square mile, because that's what it's going to require, especially as you go up in frequency. So we know that. So we look at this as a 50-year project because it's going to be in the right of way for 50 years, and people are going to see it, or maybe not. We'll talk about that later. And you have a deployment budget. We get it. It's not really that important to us what your deployment budget, because from our position, you're putting in a capital project and you have decades to recoup your investment, since it's going to be in the right of way for decades. So doing it right when it goes in, it's never going to get better than when it goes in. Mm-hmm. I think most of you, if you think about that honestly, you'll agree. Projects don't improve with age. These are not fine wines. These are small cells. So let us give you some examples of things that we see that have gone in for small cells. Smaggle-bloggle. And this is an early deployment of a small cell. I'm sure that all of you can recognize the design, at least by its component parts, as to who probably is the putative owner of it. This is stuff that it's going to be out in the right of way forever, practically. And this is not what local governments generally want to see. And for first deployments and getting it out there, that's fine. But this is certainly an early generation of a small cell of this particular design. And thank God that they're not being deployed anymore. Squash-a-blobble. And this is a more current small cell deployment prototype for 5G. As I call it, a light standard cleverly camouflaged as a small cell site. This is also not what a lot of people want to see in front of their homes. You can imagine that from a technology standpoint, this is pretty cool stuff. This is really pretty cool stuff, but we're not in the role of being technologists here. We're not in the role of being deployment experts. We're in the role of trying to serve a community need. And certainly no one disputes the fact that there are more cell phones now than home phones. But how you do it becomes that much more important, because of the fact that there are more cell phones than home phones. When I'm looking over here, by the way, I've got the presentation in advance on another screen, so I'm looking at what's the next slide coming up. Just to keep you happy here. What's the trigger word for ugly bugly? Yeah, do you really want this in your neighborhood? And I'm thinking that the majority of you probably don't, but we understand an important element here, which is your job is to build as fast as possible, as cheaply as possible. That actually is your job. We understand that, because your duty is not to the community. Your duty is to the shareholders of your company and the company you're contracting with if you're not the carrier itself. So there's a conflicting issue here, and I raise this because understanding the fact that you're doing it on the cheap is exactly what you're supposed to do helps you to understand the discontinuity with the planners who don't want it done on the cheap. They want it done on the long term. Blamel, whamel. So as we look at and we've been showing you various types of deployments of small cells, generally here in the Los Angeles area, since LA seems to be, in Southern California seems to be a pretty darn good test bed for the myriad number of designs that are out there. And one of the questions that we ask when we're on the planning side is this a candidate for a pole replacement? Should the existing wood pole, which is probably just an abandoned, well, in some cases, an abandoned drop pole with a light on it like this one, should it be replaced with a standalone light standard, a new luminaire? Notice this one is not LED. Everything now going in is LED, at least in the jurisdictions we're working with because of power efficiency issues. And can we do better than this? I mean, that's the question. Can we do better than this? Because again, this is going to be crap in the right of way for a long, long time. So one of the things that is, even on a design like this, it can be improved many different ways, mostly by cable management, interestingly, and by shrouding the base of the antenna where the cables connect to. There's just, it seems, well, the feedback we hear from the industry is, these are silly little things you want us to do. Yeah, they are. They're silly little things that actually improve the visibility for the people who live near this site. And I'm not talking about this site in particular. I'm talking about this site in general. Why don't we move on here, Tim?
Yeah, so we know residential areas are definitely some of the hardest areas to gain approvals in. So what kind of feedback do you hear from the residents regarding small cells in these areas?
Laurie, why don't you take the next portion of the slide? We'll kind of team tag on this one. So squaggle blobble.
So some of the things that we mainly hear is they're scared on their safety. They're scared on their children's safety, that they're going to get hurt. Also, the NIMBY effect is not in my backyard. They don't want it near their homes. They don't want it near their children's daycares and schools. Or they would be like, I have an XUNU carrier and my service is great. And I don't need a WVX tower in front of my yard. Or why here? Why not 2 blocks away? So everybody will try to push it out from their own specific neighborhoods. Another thing is that they would say, we have a garden that we have planted many years ago, and it's in my front lawn, and you're going to come and dig it for days. You're not going to make sure that all the vegetation is replanted after you're done. So there's many things. Or one of the things that we hear is that their home value is going to depreciate. They're going to lose approximately 20% of their value.
And NOPE stands for not on planet Earth. Let me expound on what Laurie's started to describe here. It's going to hurt me. It's going to hurt my children. We actually, starting in the next slide, have a series of slides that I want to use as a teaching. No, Tim, I didn't say the magic word. All right, thank you. Gosh, Tim, take your hand away from the mouse. We'll get it. Okay, good. Keep your hands in plain sight. It's going to hurt me and my children is probably the single most important issue that you have to deal with in terms of educating your public works people, the community, the elected officials. And the next I think 4 slides, we're going to be talking about that in a bit of detail about how we do it, how we actually teach local government officials about RF safety, which ties into the concept of not near home, schools, daycares. These are considered by the public as being particularly sensitive users. And specifically, there is more concern, much more concern over 5G than over 4G. And if you ask the average resident what's the difference between 4G and 5G, you get a lot of different information. But the information you get is somehow it's magically different, and it will cause different effects. That RF at 4G, whatever they define 4G as, causes this, and we'll talk about what that is. But 5G causes something different, something more. And I'm sure many of you who have had construction crews call in saying, Mrs. Jones just walked out in the front yard and she's demanding we leave, and we can't dig up her property. Which gets into the next one, which is understanding what the right-of-way is. Because look, most, but not all, most small cells are going to the public right-of-way. There are small cells that are going on top of buildings, but those are in relatively few cases because, frankly, like, the carriers don't want to pay rent. And in most jurisdictions, the rent you pay for the access of the right-of-way in some states is very small. In some states like California, we're not allowed to charge rent for the right-of-way. There's a settled case on it. So it's generally cheaper to go into the public right-of-way than it is on buildings. And frankly, in residential areas, you can imagine why there just aren't buildings to go on to in residential areas, deep into the residential communities. So understanding the right-of-way and who owns the right-of-way plus who is actually controlling the right-of-way are often two different things. But this is an issue where, as a practitioner of the deployment of small cells, you need to be able to talk competently to the public works people who deal with small cells and who deal with right-of-way issues on a regular basis. By the way, as we're going through, I want to encourage you to upload your questions. We're going to absolutely answer all of your questions here. So as we're doing this, don't wait. Type in your questions into the question chat box, and we'll definitely get to them. Here's another biggie. My home will lose 20% of its value. I'm sure that most of you, or many of you at least, have heard that. And interestingly, that comes historically from some studies that were done many years ago, primarily by a researcher in New Zealand, and some follow-ups that accorded a price diminution of 20% if a small cell equivalent, there weren't small cells then, if a small cell equivalent was put within some geographic distance from the home. Interestingly, that geographic distance was typically larger than the distance required not to be able to see the site. So, but the result of this has been that there is a mythology built up around the fact that if you have a cell site near your home, 20% of its value goes away. Not 19, not 21, 20%. When I was doing my doctoral, so I have a doctorate in law and policy from Northeastern University. I completed my education back some years ago, and this is actually one of the areas that I studied was price diminution, and it's just not there. And I suspect most of you realize now that the crossover that has occurred between home phones and cell phones, home phones going less than 50%, cell phones going greater than 50%. People actually go into homes now and they're holding their cell phone as they're walking around to actually determine what the coverage is inside. And optimally what they're looking for is bathroom coverage. They want bathroom coverage. Bathroom coverage? What's that? Well, if you think about it, in many cases, the bathroom is an interior room surrounded by a lot of metal, piping, wires, so forth. It's several walls in. So if you're hooked on the 10 dB per wall theory, there's quite a bit of drop if you're hooked into that. But if you can provide bathroom coverage, you can cover the entire home. And that's what the carriers are trying to accomplish. And frankly, people want to see how much coverage there is in the home they're considering buying. So the 20% diminution in value is, I'm not going to accord it the status of urban myth, but its basis is shaky at best. And then you'll always have people who say, nope, not on planet Earth. And we know that's not going to be very helpful. Not yet, Tim. Take your hand away. All right. Good. So all of these, as you can imagine, save for one of them, all of these tie into probably the most difficult issue you as deployment people face. And I'm going to really deal with this one face on, which is the issue of RF emissions. And this is the issue that concerns people the most. Consequently, this is the issue that planners will focus on. Consequently, this is an issue that the electeds focus on. Now, as I go into this next section, I want you to understand that the law on this is crystal clear in terms of the fact that the FCC has accorded national standard setting to the FCC. And I don't think anybody, well, I was going to make a generalization. Let me go a different direction. People go to the city council, they go to the planning department, they go to the public works department, and they say, you can't do it, it's going to hurt my kids. Number one, the bullet. Shouldn't say bullet here, I suppose. But the practical reality is local governments are not allowed to consider health effects to the extent that a proposed project complies with the FCC rules. Plan to comply. Laurie will deep dive into this a little bit later. But one of the things I have learned over many years is that most siting professionals do not know how to even describe the FCC rules in any way that people understand in terms of what they mean and how they relate to the real world and what the FCC's safety margins are built into the rules. So we're going to use a teaching tool, Squaggle Bobble. Okay, Tim, there you go. So we're going to learn to talk about RF. And to do this, I'm going to show you the teaching tool that we use and we've used for many, many years in front of planning commissions, in front of elected officials, in front of APA when we're teaching wireless siting to members of the APA. I'm sure there are a lot of you out there who are members of APA. And it's a 12-inch ruler. It's a 12-inch ruler. So to explain the FCC's rules on RF safety, you can talk about milliwatts per centimeter squared, microwatts, any watts you want, but people don't understand that. So you have to teach this to them in a way that they understand, and this is how we do it. So the FCC was charged by Congress in 1996 as part of the Telecom Act of 1996 to come up with national standards for RF emissions. And they did. And the purpose of that was, prior to 1996, there was a patchwork of RF standards. So you go to one community and they had one standard, and you go to the next community, they'd have a different standard. And it was very difficult, for obvious reasons, for an RF emitter to comply with one rule in one city and a different rule in a different city. So Congress resolved that by saying, FCC, you set the standard. And they did. Side note, right after they did, I was part of a team that developed probably a guide that many of you use, which is the State and Local Government Officials Guide to Transmitting RF Safety, the LSGAC guide. And it's 2-page form. So that was work that I was privileged to be part of back in 2000. So let's get to actually using this teaching tool. Now I'm going to pose this as a series of questions, and since I don't have the ability to ask you for specific feedback, I'm going to walk you through what we generally hear. the FCC was charged with setting a standard. So where do they set it? Let's, here, I'm gonna look at the next slide to make sure I'm good. Tim, go to the next slide, please. So assuming that for this purpose, we know that the 12-inch mark on this rule, that's the point where you could actually measure something, and that something is an increase in temperature. And we know that RF causes increases in temperature because probably the vast majority of you on this webinar and watching later have 1,000-watt transmitters in your home, right? You know you have, for the most part, 1,000-watt transmitters. Some of you actually have 1,500-watt transmitters in your home. And for those of you who are still scratching your heads, it's the one that's located, the transmitter that you keep in your kitchen, on the counter or above the stove, and you use it to heat food. And we know that RF causes increases in temperature. So assume for this point of this discussion that the 12-inch mark on our ruler is the point where where RF at some frequency and some power level will actually cause a measurable change in temperature. Okay, not yet, Tim. So the FCC then had to set a standard somewhere less than 12 on this ruler and somewhere greater than 0, because we know 0 means no emissions, and that doesn't work in wireless. It's a strange concept, but 0 emissions does not work for wireless. I think we can agree on that. And you don't set a safety standard at the point where you can actually observe an effect from RF. So somewhere between 0 inches on this ruler and 12 inches, the FCC had to set its general population, uncontrolled gen pop standard. And when I ask this question in audience setting, I say, where do you think the FCC set its standard? 10 inches. Okay. 6 inches. Okay. 1 inch. Okay. And the FCC ended up setting its national standard, not numerical now, but at the percentage basically of between 0 and no emissions and the point where you can actually observe a causable effect. Next slide. The FCC set it, I'm hoping you can see that on your screen, it's a little bit cut off on mine, at 0.26%. I'm sorry, 0.26 inches, which numerically has a relationship between the point where you can observe a measurable effect and the point of the maximum exposure to the public. It's 50 times more than the maximum 100% gen pop limit. If you can describe this, if you can talk to electeds, if you can talk to planners, if you can talk to the public and say, look, I understand your concern, but the FCC has national authority to set these standards, and they did, and we can't change them. And the local, and this is really important, the local jurisdiction can't change them, nor can they even adopt the FCC standards as their own. Then the next step is to talk about small cells. And let's go to the next slide. So then you have to be able to talk about the fact that small cells operate at a small fraction of that 2%. Because why? Well, number one is because we know that small cells are to have a limited coverage area because we want to reuse the frequencies for capacity purposes, and you want to keep the network balanced. So it's not like these are screamer sites. They're not. These are not macro cells in front of someone's home, although those exist. But small cells operate at a small fraction. I'm deep diving into this because this is the number one issue that the public raises. And this is the number one issue that most of you out there just fall over your feet trying to get away from it. People who say, oh, you're not allowed to talk about it, you're restricted by the FCC. That is factually incorrect. And you get nailed on it. And by simply saying we can't talk about it, you've not given the public or the public works people any comfort here in being able to approve the project. So if you can learn how to use a 12-inch ruler as a teaching guide when you're in front of a planning board, Again, this is how we've done for many years, and it's an effective tool when you learn how to do it. What is the one word that I have not used in this entire discussion? It's the word that you love to use, and I never can understand why our industry, and I consider ourselves part of the wireless industry as we are, why does our industry love the word, I'm going to whisper it, radiation. Why do we love that word? It's technically an absolutely accurate word. And it scares the bejesus out of a lot of people. You want to, my children? If you notice the entire lecture, I have not used that word except the 2 times I've just used it. I've talked about RF emissions, which is an absolutely accurate statement, which has a far different connotation. If you can please stop using the R word. The R word is the F word to us, because it just makes our job in trying to get small cells approved much more difficult, because that's the trigger word. So use the correct word, which is not the R word. Use emissions, transmissions, any emissions you want, but don't use the R word, please. All right, with that, we're going to move on.
Okay, given the sheer variances in approval processes by the jurisdictions, Jonathan, what are some key considerations for installing small cells in the public right of way and streamlining that permitting process?
And that's really the key part of this lecture. So again, our perspective is from the perspective of the other side of the planning counter, the other side of the public works counter. And the next slide, Laurie's going to take the first portion of it, and then I'm going to take the second portion of it. But it will help you to better understand what we have found to be best practices in terms of moving projects forward efficiently. Now, is efficiently fast? It's as fast as the process will take. So we'll go with that. So squaggle blobble. Laurie?
So quite often when we process applications for jurisdictions, we notice that a lot of the documents are severely lacking what the actual application requirements are. So the best practice would be to actually read the application before you submit, read the ordinance, and also check if the jurisdiction has a small wireless facility policy adopted. Another thing that is important is when you're submitting a request for a small wireless facility, ensure that your application is actually a small wireless facility. For example, you have to check all the criteria. If you're submitting for 1 antenna, make sure that the cubic foot for that antenna is less than or equal to 3 cubic feet. That would make sure that that criteria is actually satisfied. And also you have to make sure that the remaining small wireless facility criteria is also met. Another thing is that communication is key with the planner. When you're going to submit an application, ensure that you're talking with the planner. The planner actually will give you some guidance and tips on how to submit the application for that specific jurisdiction. Another thing is that if you have multiple applications to submit for a jurisdiction, it would be beneficial to submit only one application first, because at that point, you will learn the process, you will ensure that mistakes are not trickling down into the remaining applications, and also in the long run, it would make your process more efficient because you would know how to submit it. Each application is unique. When we say that, we mean that a small wireless facility is going to a unique surrounding, a unique location. So ensure that you're not submitting generic material. Submit site-specific plans, site-specific radio frequency, site-specific photo simulation of that specific application. In California, Americans Disability Act is really important. When you're processing an application or submitting an application that is going to require, for example, a light standard to be relocated or shifted and moved, you have to ensure that the plans are depicting if ADA is being met and ADA is being cleared to ensure that wheelchair accessibility is still in place.
Now, ADA compliance comes into play twice. Number one is what Laurie has just described, which is the physical component of ADA. Do you have enough room on the sidewalk for wheelchairs? That's primarily the most important criteria. Members of the public will tell you that ADA also acts as a defense against the installation of cell sites, because under ADA, people who are subject to RF sensitivity are harmed, and therefore the project must be denied. And that's typically the argument you hear. In fact, we hear it almost at every hearing now. Oh, under the ADA, you can't put in the cell site because someone will be harmed by it. It's just not the law. And speaking some more of the law is no inverse condemnations, please. For those of you, and most of you on this call, I know there's a few of you, hi Sophie, that know what an inverse condemnation is. But an inverse condemnation is where you propose to build a small cell, and instead of having the arm come off the front towards the street side, it goes on the back. And surprisingly, we see applications where the arm crosses over the property line, goes out of the right-of-way into the airspace of the private property. That's called an inverse condemnation, where we approve someone else to go in and build over somebody else's property. And as a local government, then we're potentially liable for that inverse condemnation. It's a legal issue, but it's an issue that comes up more and more, because as you're trying to put small cells in, and this is particularly true for wood poles, if you have something coming off the back of the pole, or a conduit or something like that, and it does cross over the property line, you're going to have the smart jurisdictions will deny your project. And you will have nothing to argue against the denial being some sort of effective prohibition, because you've basically asked the jurisdiction to grant you somebody else's property to use. Can't do it. Also, there are environmental quality rules and safety rules that apply. And the FCC has made it very clear that small cells are subject to generally applicable safety codes. The safety codes include, for example, outside of California, the National Electrical Safety Code. Inside of California, General Order 95 and GO 128. CEQA in New York, CEQA in California, coastal permit, all of these require approvals that are outside of the local jurisdiction, in some cases inside. But the key here is that if you submit your application piecemeal and don't include all of the required elements, you're going to delay yourself. And we just see it time and time again where coastal approval is required, where a CEQA analysis has to be done, where frankly, GO95, that by the way, when I say I don't mean you personally, you know that, all right. But where your projects don't comply with construction codes, NESC, GO95, GO128, things like that, those are just they're just going to bog down your project. You're going to be stuck in planning or stuck in permitting for a long time. You don't need to. You want to get the project done as fast as we do, which by the way is really what we want. We hate incompletes as much as you do. We like to see the projects get pushed through and get deployed in a rational way. The next one is unfortunately a looming issue. And don't use bad PE stamps. What's a bad PE stamp? I will tell you already that we as project reviewers for jurisdictions have seen where in some cases, and relatively few, thank goodness, a PE stamp, a professional engineer stamp, has been copied off of one set of plans and put on another. It's illegal. It's dumb. We've seen situations where the PE himself or herself has stamped the plans with absolutely no knowledge of the actual facts. That happens surprisingly often. we've actually recommended to one of our jurisdictions that a particular vendor be disbarred from being able to submit applications because that's has happened. In another jurisdiction, the police are looking at filing criminal charges because falsification of a PE stamp is in most jurisdictions a violation of law. I wrote an article about this that was published last year in the Florida PE Journal. Forget the exact name of it. You can find it. And finally, don't play lawyer unless you are one. Don't tell the jurisdiction that they've misunderstood the law. That's not your job as a planning professional, unless your job is specifically to be the lawyer for the planning side of the process. We see that happen a lot. It just does not serve your interests. If you follow these tips, and probably one of the most important tips that Laurie gave you earlier is file the test application. Find out how the jurisdiction processes applications. That will help you. I will tell you finally, not on this slide, but one of the things that is a best practice is consistency. It turns out that one of the best ways to hide things is in plain sight. If you have a single design and it's been approved, vetted by the Public Works Department, it's the design that is consistently deployed throughout a community. Number one, we see less pushback by the public because they see the same thing and eventually it fades from their view. Not when it goes in and not during the planning process, but if you can say, look, we've already put 75 of these into the community and we're using the same design and everybody's getting the same thing, then you overcome the issue of, well, you're treating those people over there that live in the rich part of town better than you are treating us who live in the poor part of town. No, treating everybody equally. These are best practices to get to yes faster and to get to yes cheaper as well. So with that, I think we are going to move on to the next one, which is Squiggle Bobble. Thank you. Frankly, I think we've just talked about that, which is aesthetics. You know, you want to provide coverage and you want to provide service at the least cost. And again, we acknowledge that that's exactly what you're supposed to do because your duty is to the shareholders, not to benefit or preserve community aesthetics. But it is important to getting to yes faster. Tim, I think at this point we turn this over to you.
Yep. Thank you, Jonathan and Laurie. You know, taking, in light a lot of the stuff that Jonathan and Laurie shared with us, one of the things that Alpha Wireless that we've done is work with operators and really try to understand all of the complexities dealing with deploying small cells and taking these things into light. We also try to take that operator's mindset to it with the challenges of trying to get it deployed and come up with solutions that help enable operators deploy, also allowing the municipalities and the jurisdictions, easier yes votes for installations. Like Jonathan said, if you're seeing a consistent type of deployment, it becomes obtrusive. It's not obtrusive to people anymore. It just blends into the background. It's kind of like when you see cable plant products everywhere. Everyone's just used to it now. So what we've come up with is a patented idea here. It's called the concealed antenna node that is really designed to help optimize all those items of, how do you get rid of the cables and the coax jumpers and all those type of things and integrate it into a solution that enables the quicker yes. This is a solution that's optimized from an end-to-end perspective, to help, get jurisdictional concerns reduced, but it also helps the operators themselves from the standpoint of optimizing their end-to-end logistics and deployment processes. This is a single SKU type of product that allows you to order one device that then covers your antenna, your radio brackets, the power distribution, surge protection, jumpers, everything in one item. That dramatically reduces you know, the need for any type of logistics, you know, from a purchasing all the way through to deployment, because now you have one item versus many different items to try to manage from an end perspective. Another real advantage to a solution like this too is that as you migrate from a 4G to 5G type of architecture, you're actually able to do that and do an upgrade to the system. And there are, you know, as Jonathan said, there's you know, there's rules and regulations around what you can do in the right of ways and stuff. And one of the things that we found is that, you know, if you just upgrade the inside of a particular product, there's no need of going back and getting new approvals and processes. It's just an internal upgrade. So it allows you to go from a 4G to 5G upgrade through a seamless process. You don't have to go back and reapply for a bunch of the actual zoning processes. It reduces your time to market and helps you get your deployment for any upgrades done faster. And you know, that's very modular. So, you know, we have a couple different samples here where we have the radio integrated inside on this particular unit that has the power distribution, your surge protection, and your backhaul all into a single unit. That's very fast to deploy at the cell site. And then we also have a separate unit that shows where we actually put the radios at the bottom. So you can put radios at the bottom. And then likewise, we have options where you can actually integrate the millimeter wave radios, like the pictures we saw earlier, that the radios are standing out in the open. We can actually conceal those all within one of these units. So you can have both mid-band and your millimeter wave all into a really nice small package that's very, very aesthetically pleasing. You know, another key thing to an approach like this is, you know, it's really designed to really help drive cost out of the network, because as you're looking to deploy, you know, we're seeing numbers, you know, of, you know, 10,000, 40,000, 50,000 small cell deployments. At that point, cost does matter. I mean, if you can cut the cost out of a deployment in half, that's very significant. We've actually have a proven business model that we've validated with the tier 1 operator here in North America, you know, and shown these numbers are real. You know, a 56% reduction in cost. It was driven a lot from the cost of labor, because the labor differences of hiring a crew to do all the work in the field at a site is much more costly than pre-assembling, testing, verifying there's no issues with your small cell before it actually hits the site. And that labor rate for a manufacturing type of individual is substantially lower too. So it is a very cost-effective type of approach. So, you know, why choose the CAN type of solution? Well, it really is reduced, you know, site approval times. You know, when you go in and meet with the zoning groups, you know, they're more apt to adopt something like this. We've met personally with 3 different CIOs in different cities. All of them have been very receptive to the approach. When we first actually deployed this unit in Columbus, Ohio, the individual who took it in there for approval was actually asked by the zoning group to change all of their applications to this particular one, and got all of them approved at one approval process. It makes the deployment much easier. You know, when they go out to a cell site now, or out to a small cell site now, all they have to do is hook up the power and your backhaul. Everything else has already been done, tested, and verified in your facilities. So it's your quality goes way up, you know, by doing that assemble, wire, and test at the manufacturing point of reference. And then also, you know, it will allow you to increase the number of access points or locations you can get to within the urban and suburban areas, because again, it will blend in much faster and easier with people when they don't see a bunch of wires and cabling and everything else hanging and radios down low. And so it is very much appreciated by everyone that's actually seen them. Here's an overview map of where we have product of this nature deployed today. You know, it's again, it's been deployed by tier 1 operators. There's when they start deploying them in the cities, the approval process has become a lot faster because it's consistent, it's repeatable, and it's less obtrusive. And then, it's just overall, it becomes a very easy way to adopt and get into deployments. Here's a couple just quick snippets of a couple that we have here. One is on the right there is at the Las Vegas Convention Center. It's deployed right outside of the center itself. We walked around there at Mobile World Congress for 2 or 3 days and didn't even notice it. And finally, one of our colleagues actually noticed it, and we were able to take a picture. Again, it just kind of blended in. The one on the left is our 2nd generation product. It's a multi-carrier system. So that one there itself has 2 different frequencies in it, but we have the ability to do 3. And if you need to do microwave type of solutions, we can accommodate those as well. Like Jonathan was showing earlier, do you really want some of the big macro sites looming in your neighborhood? And not too many people do, and they do look pretty cluttered. Here's a couple of samples of what we call our canister deployments, where this is a full macro solution where there's 3 sectors inside of it. So it's what we call our AltaFlex line. It includes multiple sectors, multiple frequencies in there. The one on the left is on a right-of-way type of deployment right next to the road. It looks just kind of like a street light, big street light. And then the one on the right is one at a restaurant bar area that's sitting in the back parking lot. So it's integrates very nicely and becomes part of the landscape and is able to be deployed quickly.
Tim,
I'm going to hand it back over to Anne-Marie, and she's going to now open up to Q&A portion. Thank you.
Tim, before you do that, would you go back 1 slide, please?
Yes.
And from our perspective on our side of the planning desk of the Public Works counter, where you can deploy something like these types of designs, and again, we're not here specifically recommending any particular vendor, but these types of designs are important for a couple of reasons. Number one, and I'm sorry, there's really no better way that I can, well, there probably is. All right. As many of you know, one of the deployment techniques is to use a large radome on top of a unipole. We have a feminine product description of them, but for this we'll call it dog on a stick. If you compare that dog on the stick design to a design like this, it's far easier for us to recommend approvals of the uniform diameter poles than it is for dog on a stick or feminine products. And it just is less intrusive. On the picture on the right-hand side, you'll notice that there's a light attached to it. So it's actually providing a public benefit, a secondary public benefit, in addition to wireless. It's providing illumination. And that's one of the ways to get to yes faster, is to show that there's a public benefit by providing illumination where there may not be one and illumination is needed. So keep those in your quiver of decision points to help you find a design after you've talked to the Public Works Director or the Public Works planners, whomever. Find out what they need and give them what they need, because frankly, when you do, you can imagine that your yes process is a lot faster. So thank you.
Thank you very much, Tim and Jonathan and Laurie. So we have lots of questions that have come in. So just in terms of looking at time, we may not get to all the questions, but certainly we'll follow up afterwards if yours hasn't been addressed. So we'll do our best. So the first one has come in, and there's a few come in from Alfonso. So in terms of if most of the public believe that broadband connectivity should be viewed as a utility, Why wouldn't government agencies seek to adopt a quick and rapid deployment of such? And I suppose looking at it in terms of developing a universal standard for aesthetic deployments, it seems to vary by jurisdiction in the country. So how can rapid deployment be achieved if there's no universal standard of aesthetic acceptability?
There never will be. Number one, there simply never will be, because we are a group of 50 states plus territories. And because of the federal local relationships, it is not possible, in my view as a lawyer, much less as an RF engineer, it's not possible for the FCC to say, this is the national standard, and if a carrier does this, you must approve it. Now, they've gotten close, like in small cells for the cubic footage issues, but they haven't said what it has to look like, because that does cross a line and 10th Amendment issues come in. But getting to the earlier question about why shouldn't this be done as rapid deployment, government agencies seek to adopt rapid deployments and so forth, it gets to a more interesting question, and one that most carriers don't want, which is, why shouldn't there be regulation at the state level PUC? Now, in a couple of states, Connecticut and New Jersey come to mind, there is state level regulation, or at least some level of state regulation. The problem is when you have state level regulation, you get a kind of a one size fits most scenario. But take the situation where you've got a flat community versus one that has no straight street in the city. One of our clients in California is a community that has no sidewalks. It has literally no straight streets in the city. And the elevation changes are dramatic between various parts of town and even within neighborhoods. So if you start talking about there should be a state standard, a federal standard for what it is, it becomes problematic to you more than to us. Because for us, it's just, well, okay, you came in and you didn't have the cookie cutter because, well, it's not gonna provide the level of coverage you want, but tough luck, you didn't fit the cookie standard, so project denied. There are problems with this, and frankly, not every community is the same. Some communities have more sensitivity than others. I think over time, one of the most interesting issues that should terrify the industry is that as the crossover continues between home phones and cell phones, and when the states start considering the fact that cell phones are the telephone company, they're going to ask themselves the question, why aren't they regulating much more than just the installation aesthetics? Why aren't they regulating the wireless companies much more closely? Now, there's some problems with that because of the fact that it's using radio waves versus cables. But most of you will remember that there's a lot of cabling involved in wireless. You can't do wireless without wires. I think that's a quote from the California Wireless Association. I hope I've credited them correctly.
Brilliant. Thank you very much. Yeah, so I'm on the next question. So again, for Jonathan and Laurie, this is coming from Paul. So Europe has adopted presumptive rights to deploy small cells nationally and internationally rather than jurisdiction by jurisdiction. How is this 30L 1 cubic feet? Can the US carriers live with a similar relatively compact small cell standard?
Both Laurie and I had the privilege of going to and graduating from Strathclyde Law School for our Masters of Law degrees. And so as part of that, we studied European telecommunications law. And the answer is that the EU is a far different animal than the way that the United States is configured. Where the EU has a strong international governance system, and the members of the EU adopt the regulations in one form or another that are created by the EU governing boards. Here in the US, it's just different. As to the question of the cubic size and the fact that Europe has a different standard for the size for small cells, can it be adopted here in the US? The answer, of course, is no, because the FCC has ruled that it's 3 cubic feet for antennas and 28 cubic feet for everything else. So that's our national standard. The actual configuration of it is less, but no state or no local jurisdiction could say, we adopt the European standard for the city of XYZ, and you can't do larger than that. It's simply illegal.
Thank you, Jonathan. And next one coming in from Doug. He said, is the FCC standard based on biological or toxicological studies or based on manufacturer's data?
Hi, Doug. The answer is yes. And let me explain. When the FCC set its standards, because understand, please, that there are 2 main standards. Number 1 is the GenPop standard, uncontrolled GenPop standard. The other is the controlled, the occupational controlled standard. One of the ways, by the way, that you screw up when you come to the planning counter is to bring an RF report that uses occupational. It'll get bounced by us almost every time, because in virtually every case, the GenPop standard applies, and the GenPop standard is much more restrictive than the occupational standard. Now, Doug, to answer your question specifically, the FCC standard was based on a review of the science at the time and looking at standards in a variety of countries, going out and talking to US government agencies, talking to the private radiological health entities, talking to the carriers, and the FCC had to set its standards somewhere. So when it did, it set it at, if you remember back to the slide, the 2%. Now, this is an important talking point for you folks when you're talking to the public. Well, you know, the country of adopted a standard that is twice as restrictive as the US. Yes, they did. Well, we shouldn't have that here. Okay. Do you know the effect of adopting an RF standard that is twice as restrictive on cell sites? Yeah, they're going to have to lower their power. That's absolutely correct. And because they have to lower their power, if they cut it in half, inverse square rule applies here. They're going to have to they're going to have to quadruple the number of sites to serve the same area. So by cutting the power, you actually require more cell sites in an area, not fewer. And since we're talking about something that is only 2% of the point where you can actually measure a measurable effect, what are you gaining from safety perspective? And the answer is, I don't know. So now, Doug, that's half the answer. The other half of the answer is that the FCC recently completed a multi-year, decade process of reviewing the RF standards for adequacy. And they basically said to the public, tell us that our standard is wrong and tell us scientifically why. Didn't happen. So the FCC readopted and basically reaffirmed their own standards for cell sites. Now, they did make some changes for standards for handsets. That's not within the realm of this conversation. But the FCC standards are based on going out to other expert agencies, going out to the public, going through a rulemaking process, going through a question and answer process. So the FCC continues its 1997 standards in effect. Oh, but they're from 1997. Things have got to we've got to have learned more, because remember, smoking, cigarette smoking. Yeah, and this isn't that. And this is different, and this has a much deeper scientific basis and a public participation process. Doug, I hope that answered your question.
Thank you very much, Jonathan. So this is more as a statement from Sophie, who's saying thank you for the shout out, Dr. Kramer. In my experience, we have avoided the issue of inverse condemnation by entering into a separate agreement with the LL, I believe, landlords for the portion of their property that would be encumbered by any portion of the proposed WCF.
And that's the right answer. A better answer, however, is, do you desperately need that particular pole? And look, there are very, 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 very few times when there is one and only one place a small cell can go. Remember that you are afforded a guarantee of coverage under law, but not the best or the cheapest. It's not the least expensive means, it's the least intrusive means for those jurisdictions where it applies. And as the FCC's small cell order was preempted in part recently and is under appeal for the rest, our law firm is one of the firms that are suing the FCC. The FCC's aesthetic rules, which largely preempted local governments, was struck down by the court. So we're still in the aesthetics business. So if a jurisdiction says, you know what, we know that you need to provide coverage, you've shown us that that's what your goal is, but you need to go the pole across the street. Well, it won't provide as good a coverage. That's not the answer. You got to work it out. Or maybe it's a new pole in the right of way, or maybe it's a new light standard. But getting back to Sophie's point, if you do need to cross over to private property, do exactly what she's doing, which is you have to get an easement from the private property owner. And if you can't, sorry, move on to the next site.
Perfect. Thank you, Jonathan. And the next one from David. So small cell antennas are allowed to 3 cubic feet, equipment to 28 cubic feet. How is the cubic footage of the pole top assembly characterized as to antennas versus equipment volume?
The FCC 28 cubic foot rule does not include camouflage. The FCC's aesthetic rules don't consider cubic feet. So now you have a balancing between cubic footage and aesthetics. And don't forget that it is within our authority to say, yes, you want to put this amount of equipment here, congratulations, put it into a vault. Oh, but we'll lose the manufacturer's warranty. You can't make us lose it. Of course we can, because we're not subject to the manufacturer's warranty. We're subject to the planning to minimize the impact on the right-of-way. And in California, there's even a California State Supreme Court ruling on that we still maintain aesthetic control, what's called incommoding the right-of-way. And don't even ask where that word comes from. It's from literally from the 1920s. But these are the balance points. Yeah, if you want to fight something, you're going to spend a lot of time fighting it because you want to do it on the cheap. You're going to find that you're going to end up inevitably spending more money and not getting what you wanted anyway. So work with the planners, work with the public works people to find out an approvable design. Because look, I think most of you will agree, this is a time to market issue. You want the site on air as quickly as you can. And if you're a builder, you want the site on air as cheaply as you can. Well, it may be that you can't make your margin of 40% or whatever your margin is, but maybe you go down to 30%, but you get the approval 6 months faster. You decide which is more important.
Thank you, Jonathan. This one comes in from Craig. Are the municipalities anticipatory of a need to verify emission levels? Statements made by the presenters that emission levels are reducing for small cell is not quite accurate. Performance attributes, beam forming, steering within current transmission protocols that result in larger emission levels.
And that's true. Unfortunately, on a webinar like that, we have to generalize because we're trying to talk to as many people as we can. And there are going to be situations like what you've described where the emissions will require a deeper level. Understand that the FCC rules CAT-X sites that are where the bottom portion of the transmitting antenna is greater than 10 meters above ground level. in most cases on light standards, that doesn't happen. So you're going to have to do a more detailed RF analysis anyway. So in a lot of cases, small cells that don't use steerable technology, don't do beam forming and so forth. You know, we're talking more of the 4G flavor than the 5G flavor. Again, we can get down to picking apart exactly what we're talking about, but for the general purpose of this, most of the sites are going to require a detailed RF analysis anyway to get the clearance for those jurisdictions that inquire, and not everyone does. So, you know, roll your own and figure out how it goes on in your particular jurisdiction.
Great, thank you. So next one from Thomas comes in. Is there a typical height needed or required for a 5G deployment?
Is there a typical height needed for 5G deployments? Well, most of the time, from what we see on our side of the planning counter, you want to be above the roof level of the adjacent homes so you can look down into them. You want to be above or clear of clutter as best you can be, but not in every case. I mean, we're seeing 5G sites that are literally next to trees. So there's no height requirement. If there's any height requirement, it's going to be more related to RF safety and compliance with the gen pop limits than it is, because once we get into transmission needs, we don't care. That's your department. We care about compliance with safety codes and aesthetics.
Excellent. And then one for Tim. This is back to Alfonso. So do you have to conduct structural analysis for every single CAN antenna deployment that might be deployed on different street furniture like streetlight poles, utility poles, and or other municipal infrastructure?
Yeah, there is a requirement for them to go back in and validate and that the structural analysis will support the solution. The good thing is that all utility companies use a very common pole throughout their jurisdiction, and the same with lights. You know, there's a standard design that they have. So typically if they know that there's a particular make and model of street furniture out there, that once they do it, it'll verify for the other ones. If it does come into a play where it does not support it, most of these light companies nowadays have like for like type of deployments that have a thicker wall structure, and then allows it to support the heavier weights on them.
Excellent, thank you very much, Tim. There's one here from Mark. So looking at the local government's understanding about FCC RF limits are not intended to prevent headaches, insomnia, tinnitus, fatigue, DNA damage, cancer. Do they understand that the FCC RF limits are only intended to prevent what the IEEE defines as established adverse health effects in C95.1, and that the definition is very narrow and covers only extreme acute exposures? So,
Mark, that's a very well-formed, loaded question. So let's unpack it a little bit. Do the governments understand that the FCC limits are not intended to prevent headaches? That's not what the local governments should be considering. Under settled law, under settled court jurisdiction or court rulings, we're looking for compliance with the FCC rules. That is the standard. To the extent that you've raised an issue that we hear repeatedly, which are generally grouped together and called non-thermal effects. Non-thermal effects. It's a reality that's simply outside the scope of the local jurisdictions to make decisions based on that. This is what I spoke to earlier, and what Laurie does a tremendous amount of is looking for planned compliance with the FCC rules. Why planned compliance? Because the site isn't built yet, or it hasn't been modified yet. So that's why the RF reports become such an important tool as establishing prima facie that the project will comply with the FCC rules. And if it does, that ends the local jurisdiction's inquiry into the subject. So when we talk about headaches, insomnia, tinnitus, fatigue, allegations of DNA damage, cancer, whatever you want, that is simply beyond the scope of what a local jurisdiction is allowed to deal with. And as for your reference to C95.1, when we're looking at C95, we're looking at the signage requirements. And now the FCC has even modified that most recently with its RF order. But the bottom line to your question is, our exploration of the question of RF safety is, does it comply? Does it show plan compliance with the FCC rules? If it does, then that's the end of the discussion, and we move on to aesthetics and public safety issues that are not related to RF emissions.
Thank you very much, Jonathan. Next in from Kent, for you, Tim. So what is the range of installation times for these units, which I believe, I'm making an assumption here now, I believe it's the CAN, or the tri-sector canister, and degree of interruption to traffic flow? And perhaps maybe this is a question for you both, Jonathan and Tim.
Okay, so one of the things that we did when we actually did the proof of concept for the concealed antenna node was we compared a typical day of a crew putting a small cell in at a location. What we found was the installation crew varied from 4 to 5 individuals on site for the better part of a full day, to build cables, to run power up the pole, to terminate connectors, build RF jumpers, those type of things. When we went and installed the solution that we had, they were for the prototype unit, we were about 3.5 hours in time. But once the crew understood how to do it, they projected that they could actually get them out and do them actually in less than 3 hours time, more than likely in 2.5 hour time period. So very substantial reduction in traffic flow. And then also when it comes to the canister type of solutions, you're going to have to worry about building your footing and that type of capability to hold that support in the ground. But once they get that done, it's a matter of bringing a crane out. They drop it in place for a few hours, get it bolted in, and then they drive off, and then the other crew can actually terminate the connectors into the antennas at that point. So again, it would be, it's still going to be disruptive, but it allows you to put something in place that wouldn't be allowed before.
I'll add to that by saying traffic control is very important, because inevitably you're working on the edge of the right-of-way. You're blocking potentially either a parking spot or two, in which case it's probably not a big deal. But quite often, especially when you're talking about a crane to come in and lift the new pole, and if it's a pole replacement, removing the old pole, which occurs in 2 different times, you're going to need to get traffic control permits from local jurisdiction. If you don't, you subject yourself to having your project red tagged. Nobody wants to have their project red tagged. So doing a traffic control plan is important. Ask the permit specialist you're dealing with at the jurisdiction what the requirements are. Many states have statewide traffic control requirements. Here in California, it's developed by Caltrans, the state transportation department. But you are likely going to be subject to a Caltrans permit as well. If you don't apply for it, if you don't apply for that particular permit at the time you're applying for the small cell, you may very well see your project delayed, because you'll have the approval for the small cell, but you will not have the right to actually install it because you failed to include a required permit to physically do your project.
Thank you very much, both Jonathan and Tim. Dennis has come in with a question here about, please, do we need a fiber network for small cell deployment? So this is an open question to the...
Well, I mean, it's really kind of up to the operator on what they have forecasted as far as like traffic demand and load on the site. We have installations that have fiber going to them, DOCSIS, or even in some of these are original cases that actually had wireless backhaul integrated into them. So when you take those different options in account, you can do any of those, but it really needs to align with what the operator sees as what kind of traffic and access they need to be able to support that wireless demand.
I would frankly be surprised to see a great number of sites built without fiber, simply because the demand for downstream primarily capacity requires it. Upstream, not as much. We've seen certainly a national deployment of a wireless backhaul network with the mobility service for Sprint. However, apparently that's going to be going away. Bandwidth requires bandwidth, and using spectrum for the backhaul, for the downstream especially, probably more efficient ways to do it. And because fiber is so easily available now, primarily through cable TV companies who are very actively deploying fiber to cell sites, I think we're going to see more and more fiber. Will it be exclusively fiber? No, there'll still be some T1s out there. There'll still be some wireless backhauls and primarily microwave backhauls, but at small cells, probably not so much.
Yeah, especially when you layer in 5G now. You know, the demand on the 5G network with the throughputs and the latency requirements, fiber does make those type of requirements much easier to adhere to.
Thank you very much. And Gregory has sent through a question here. Do RF compliance reports require PE sign and stamp? Can cities require RF modeling reports have a PE stamp?
The first question is, do they require a PE stamp? No. It's a jurisdiction by jurisdiction decision. More and more are requiring them because, frankly, I'm sorry to put it so bluntly, but there have been too many cases where RF emissions have exceeded that which were provided without the value of a stamp. And there are still, I will still say that the vast majority of PEs like their license and are not going to be willing to stamp reports that are not accurate. And because of that, more and more jurisdictions are looking for PE stamps, and more jurisdictions are saying, we're relying on this PE stamp, and if it proves wrong, then we have a code compliance issue, and we very well may go into a code revocation process. In extreme cases where there's been a intentional falsification or the theft of a PE stamp, violations of law, we're not seeing it yet, but I would expect, given what we see, that we're going to see permit revocations. That's an ugly position to be in.
Perfect. So I think we've covered the majority of questions there. There might be a couple more, just to see if there's one more that's coming.
Yeah, I think we're going to have to cut it off with this one.
I think so.
This is an old friend of mine, so I'm glad to see he asked his question.
Excellent. So this is from Keith. So far, two affected groups in the small cell discussion have been noted: the permitting authorities and the mobile operator shareholders. Not considered are the interests, bandwidth and performance versus only aesthetics that has been discussed. For the mobile operators, customers, homeowners, Dr. Kramer's bathroom standard, who are also taxpayers' constituents, delays in permits mean they have poor broadband performance for longer than necessary. Higher installation expense will end up showing up on their bill. Homeowners are generally willing to trade off aesthetics for performance, for example, satellite dishes and fixed wireless broadband antennas.
Keith, I'm going to have to agree in part and disagree in part. I agree that the issue of deployment is one of performance versus aesthetics, but that's pretty darn important because what local jurisdictions are in the business of is public safety, generally applicable safety codes, and aesthetics. And how industrializing a residential area, and take, for example, a prime example would be one that has no utility poles, completely underground neighborhoods. Mm-hmm. So once you start putting in wireless facilities, you're going to change the character of the neighborhood. And this requires more than just, well, it's going to provide faster connectivity. There are community issues that come into effect. So there's a balance point. And does that balance point tilt in one favor or the other? At the end, there has to be a solution because the provision of coverage is one that's protected under federal law, although not necessarily the best provision of coverage or the most economical provision of coverage. So whether this appears as more expense showing on the bills, and I'll tell you what, I pay a very pretty penny to my wireless provider every month. And yet here in my home, I have a picocell because my carrier can't provide coverage inside most of my home unless I'm on that side of the house that happens to face the cell site. Now, are there alternatives other than small cells? Sure. But this gets to the larger question, which is, how do you provide coverage? It's not just related to small cells. Small cells are a very important part, but they're not the only arrow in the quiver. So thanks for asking the question, Keith.
Yep.
I'll see you at Expo.
Thank you very much, Jonathan. So that wraps up the webinar today. Thank you very much to everyone that's joined us, and particularly to our speakers today as well. The webinar has been recorded, so it will be available on demand. It'll be shared out via email, and it'll be on our website and our social channels tomorrow. So have a good evening, good afternoon, everyone.
And good morning.
And good morning.
Thank you.
Thank you very much.
Good morning.
Thanks, everybody.
Bye-bye.
A privilege to talk to you today.